So, good morning, students. Welcome to online classes, CHAITANYA PU College, Ballari. Yesterday, in physical optics or wave optics, we are discussing about Doppler effect. This concept is there in sound also. Doppler effect in sound, Doppler effect in light. What is the basic idea of Doppler effect? Doppler effect can be observed only when there is a relative motion between the source and observer. Either in the case of sound chapter or in the case of light chapter, we can observe the Doppler effect when there is a relative motion between the source and observer. The apparent frequency received by the observer, apparent frequency of light received by the observer due to the relative motion between the source and observer is called Doppler effect in light. Yesterday we derived the two formulas, two concepts. When the source is moving towards the stationary observer and source is moving away from the stationary observer, we will discuss small for the other competitive examination concepts on Doppler effect. Then we will go to the interference chapter today itself. So whenever we consider the Doppler effect for other competitive examinations, this will be useful. What we are discussing now. Doppler effect. This is the source of light. Observer. Source is moving towards the observer. Wavelength decreases. Lambda dash is equal to lambda into 1 minus V by C. Wavelength decreases whenever the source travels towards the observer. If the wavelength decreases, then what happens to frequency? Frequency increases. Yesterday derived. Whenever the source is traveling towards the stationary observer, the wavelength received by the observer will be less than original wavelength, actual wavelength. Lambda is the wavelength of the light emitted by the source. V is the velocity of source. C is the velocity of light. Wavelength decreases, frequency increases because wavelength and the frequency inversely proportional. I want the fractional change in wavelength. Fractional. So modify this one. Lambda dash by lambda is equal to 1 minus V by C. Take this lambda dash by lambda to that side, V by C to this side, which gives us V by C is equal to 1 minus lambda dash by lambda. This can be written as V by C is equal to delta lambda by lambda. Fractional change in wavelength of light due to the motion of source towards the observer. Delta lambda by lambda is equal to V by C. Velocity of light C, velocity of source V. Same way here also. Calculate the fractional change in the frequency. How to do this one? So cross multiplication nu dash by nu is equal to 1 plus V by C. Just by what? Frequency to the denominator. So bring this plus 1 to this side. That is equal to nu dash by nu minus 1 is equal to V by C. Is equal to V by C. Delta nu dash or delta nu by nu is equal to V by C. Just try to understand. Here the wavelength decreases. Here the frequency increases. Because wavelength decreases, we can take delta lambda minus. Here the frequency increases, then we can take plus. That's all. Formula is same. V by C, V by C. Fractional change in frequency, fractional change in wavelength. In case of Doppler effect, for competitive examinations, delta lambda by lambda is equal to V by C. Minus, what the minus sign indicates? The minus sign indicates that the wavelength decreases. Delta nu by nu is equal to V by C. What plus sign will indicate? The plus sign will indicate that the frequency of light received by the observer increases. In these two formulas, calculate delta lambda, Doppler shift. So delta lambda is equal to delta lambda V by C into lambda. Delta nu is equal to V by C into nu. Delta lambda and delta nu is called as what? It is called Doppler shift. Shift in the wavelength, shift in the frequency. Shift in the frequency. So this is case 1. What is case 1? Source moving towards stationary observer. The same formulas can be used. If the source is at rest, observer is moving towards the source. Same formulas for competitive examinations. Source, observer, source is moving towards the observer. Lambda dash decreases, nu dash increases more than actual frequency. These two are formulas for calculating the wavelength and the frequency. Apparent. These two, fractional change in wavelength, fractional change in frequency. Formulas are same, only the difference is plus sign and minus sign. Minus sign. Wavelength here decreases, here wave frequency increases. We can calculate Doppler shift also. What is Doppler shift? Delta nu. Delta nu is equal to V by C into nu. Nu is the original frequency, V is the velocity of source, C is the velocity of light. Observer already at rest. So case 1 over. For competitive examinations, take down quickly. We will go to the next case. Source moving away from the stationary observer. Case. Now, let us go to the case 2 in Doppler effect. Model number 2 in Doppler effect. Now, what happens to the source? Now the source is moving away from the stationary observer. Very simple. Away from the stationary observer. So in this case, because the source is moving away, the distance between source and observer increases. So wavelength increases, whereas frequency decreases. Small change. If the source is moving away from the stationary observer, the distance between the source and observer increases. So wavelength increases. So lambda dash is equal to lambda into 1 plus V by C. Frequency decreases. If the wavelength increases, frequency decreases. So mu dash is equal to mu into 1 minus V by C. Calculate the fractional change. This will become plus. This will become plus. So here lambda dash by lambda minus 1. So we will get plus sign. Because increase in wavelength. This 1 comes to this side. It becomes minus. Lambda dash by lambda minus 1 is equal to V by C. Delta lambda by lambda is equal to V by C. We'll get plus sign, that's all. What indicates plus sign? The wavelength increases due to the motion of the source away from the observer. Here what happens? Here, this is minus. Now here, we will get minus 1. 1 minus. Because V by C goes to this side, V dash, nu dash by nu comes to this side. 1 minus nu dash by nu is equal to V by C. But here we will get minus sign. That's all. What does the minus sign indicate? The minus sign indicates that the frequency decreases. Once again, the Doppler shift is given by the same formula. Delta nu is equal to V by C plus or minus V by C into nu. Into nu. If you understand, it is very simple. Case 2, the source is moving away from the stationary observer. Doppler effect for competitive examinations. Maybe NEET, maybe JEE, maybe AIMS exam. Whatever may be the name of the exam. If the source moves away from the stationary observer, wavelength increases, frequency decreases. Calculate the fractional change in wavelength. Fractional change in frequency is equal to just V by C. Velocity of source per velocity of light. We can calculate the Doppler shift also. That is, delta nu is equal to V by C into nu. Into nu. This is case 2. How to calculate the Doppler shift, fractional change in wavelength, and also apparent wavelength, apparent frequency. Apparent wavelength formula, lambda dash is equal to lambda into 1 plus V by C. apparent frequency nu dash is equal to nu into 1 minus V by C. V by C. Come on, take down this one. Doppler effect, second case. First case, source moving towards the stationary observer. Second case, source moving away from the stationary observer. In the first case, wavelength decreases, frequency increases. In this case, wavelength increases, frequency decreases. Now, overall result I will write. So in the Doppler effect, overall result, delta nu is equal to V by C into nu. Delta lambda is equal to V by C into lambda, plus or minus, plus or minus. What represents plus or minus? In one case, the frequency decreases. In other case, frequency increases. Or slightly, we can modify also. Minus plus. If this is plus, this will be minus. If this is minus, this will be plus. If the frequency increases, wavelength decreases. If the frequency decreases, wavelength increases. Plus or minus delta mu is equal to V by C into nu. Shift. Plus or minus delta lambda. V by C into lambda. Now let us go to the next concept. Very important one. What is meant by red shift and the violet shift in the Doppler effect? What is meant by red shift? What is meant by violet shift? Or sometimes blue shift? What are they saying? What does these two terms represent in Doppler effect? Let us consider this is the Earth, this is the star which is emitting the light. In a celestial body, celestine, which emits light. Both are stationary. Both are stationary. Rest. It will emit the light. Reaches the surface of the Earth. It will emit the light. Reaches the surface of the Earth. Case 1. Both are at rest. The Earth and also the celestial body which emits the light. Star, sun. It is at rest. Now it emits light. Which will emit light? Star. We are going to get spectrum. We are going to get spectrum. Electromagnetic spectrum. 7 colors. From where to where? V, I, B, G, Y, O, R. Spectrum is obtained. For the light emitted by the star, we are going to get spectrum. The wavelength ranges from 4,000 angstroms to 8,000 angstroms. With GR colors, rainbow. With GR colors, both are at rest now. Which one and which one? The Earth is the observer now. What is the source? The star is the source, which is emitting the light. Which is emitting the light. Now take case 2. With the diagram, we can understand everything. So this is that. Now this is the star moving away from that. Away from Earth. Away from the Earth. With some velocity v. With some velocity v. Emitting the light, same frequency. Light is emitted by the star. It will reach the Earth. It will reach the Earth. But we know very well, either the observer or the source is moving away. Wavelength increases or decreases? Wavelength increases. The entire spectrum is shifted towards red color. If we take once again spectrum, the entire spectrum is shifted towards longer wavelength. Which is the longer wavelength? Red color. Violet 4000. Red color 8000 roughly. So therefore, entire spectrum shifted towards what? Towards red color. Spectrum will be shifted. Entire spectrum of light. This is the spectrum obtained for the star which is moving away from the Earth. Because entire spectrum is shifted towards the red color. This is called red shift. This phenomena is called red shift. On the surface of the Earth, if you get red shift, then it means that the star is moving away from the Earth. No need to go there and see whether star is moving away or moving towards. The scientists sometimes will be giving the information. Some celestial body is coming very near to the Earth. It may collide the Earth. It will take this much amount of time. Just by using Doppler effect phenomena. NASA scientists, ISRO scientists, they will be giving information about the space, about the galaxy. Now let us consider case 3. Case 3. This is the source. Earth. Now this is the star. Now star is moving towards the Earth. Star is moving towards the Earth, emitting same light. In all the 3 cases, light emitted by the star will be of same frequency. Will be of same frequency. Now, the source is moving towards the stationary observer. Wavelength decreases. Apparent wavelength less than actual wavelength. So therefore, the spectrum is shifted towards the violet color or towards the blue color. V, I, B, G, Y, O, R. Entire spectrum compared to this one. The spectrum is shifted towards the violet color, towards the blue color, lesser wavelength. That's why this is called violet shift, or sometimes blue shift also. Nothing wrong. Wavelength decreases. That's all. So very important 3 cases. What is meant by red shift? What is meant by the violet shift? In a Doppler effect of light. Doppler effect of light. When both are at rest, we are going to get a spectrum. with GR colors. When the star is moving away, apparent wavelength greater than the actual wavelength. So, entire spectrum shifted towards red color. It is called redshift, that phenomena. In this case, the source, that is the star, moving towards the earth, towards the stationary observer, wavelength decreases, apparent wavelength less than actual wavelength, already proved. Then the spectrum is shifted towards violet color or blue color, or we will say lesser wavelength. This phenomena is called the violet shift or the blue shift. Blue shift. So this is the concept of the red shift and the violet shift in the case of Doppler effect in light. Doppler effect in light. So lastly, uses of light, uses of Doppler effect. Concept will be completed. Uses of Doppler effect. What is the use of this phenomena? By using this phenomena, we can say that the universe is expanding. Universe is expanding. How can you say, sir? We are going to get redshift. Redshift means the stars, the celestial bodies are moving away from the earth. Most of the celestial bodies moving away from the earth. By using this Doppler effect, we can say that universe is expanding. Second one, we can find the speed of the rotation of the earth. Speed of rotation of earth can be estimated, can be calculated by calculating nu dash. By calculating frequency, we can find out omega, because n is equal to omega by 2 pi. We can find out the speed of the rotation of the earth, with what speed it is rotating. Already we come across in gravitation chapter, first year concept. R omega V is equal to latitude effect of G. What is the third one? It is used in sonar. You might have heard this word, sonar. Sound navigation and ranging to find out the speed of the submarine, position of the submarine underwater, the objects moving underwater, what is their position, what is their velocity, can be identified by means of sonar technique. Sonar, sound navigation and ranging, full form. To find out the position of a submarine, velocity of a submarine, any object under sea can be identified by using the technique of sonar. It is used in radar also. Radar, radio detection and ranging, radio waves. Radar, position of an airplane, position of a rocket, velocity of rocket. Like that, aerospace, we can find out the position and also the velocity. From now also, if an airplane is to be landed in the airport, They will get the signals from radar, whether to get down or not, atmosphere is suitable or not, helicopters, aeroplanes, rockets, everything. We can study by using Doppler effect phenomena. We can find out apparent frequency. With that, we can calculate the velocity. The last one, we can find out the temperature of the plasma. Fourth state of matter. In stars, temperature of plasma. We know that the matter exists only in three forms: solid state, liquid state, and the gaseous state. There is a fourth state is also there. That is called plasma state. At very, very high temperature, the matter exists in the form of ions, not atoms. That is called as a fourth state of matter. That is plasma. We can find out the temperature of the plasma. First year once again relation, Wien's displacement law, thermal radiation. Knowing the wavelength, we can find out temperature. Lambda into T is equal to constant. Is equal to constant. If we know the wavelength of the light emitted by the star, we can find out the temperature of the star by using Wien's displacement law, thermal radiation chapter. So these are the uses of Doppler effect. The first one, we can say that universe is going to expand. The speed of rotation of the earth can be found out. It is used in sonar. It is used in radar. Sonar and radar. Sonar to find out submarines, position, velocity, direction of motion. Radar about space, airplanes, helicopters, rockets, satellites. What is their position? What is their frequency? What is their mass? What is the velocity? Can be identified by calculating nu dash, apparent frequency. Lastly, we can find out the temperature of the celestial bodies, stars, by knowing the wavelength. By knowing the wavelength. Now, Doppler effect. In sound. Doppler effect. In light. Doppler effect in light. Symmetrical. Doppler effect in sound. Unsymmetrical. Means what? Here, the frequency in case of sound, apparent frequency, changes whether the source is moving towards the observer or observer is moving towards the source. Different formulas, but here same formula. Either source is moving towards the observer or observer is moving towards the source. Only one formula. Here we will have 8 cases. But here only 2 cases. Either the source moving towards observer or observer moving towards the stationary source. Only one formula. That's why the Doppler effect in light is symmetrical. It won't depend upon whether source is moving or observer is moving. But Doppler effect in sound depends on whether the source moving towards the observer or observer moving towards the source. Different values. That's why the Doppler effect in light is symmetrical. The Doppler effect in sound is unsymmetrical. unsymmetrical. So with this, complete Doppler effect concept over. Complete Doppler effect. Now I am going to go for the interference chapter. Interference, then diffraction, then polarization. Polarization. So let's see the definition of interference. We are starting the new unit of the physical optics or the wave optics. So what is meant by interference? Very important chapter. Already discussed in this wave optics, 3 subtopics: interference of light, diffraction of light, polarization of light. These are the 3 properties exhibited by light in wave optics. In geometrical optics, we completed reflection, refraction, rectilinear propagation of light. Now let's see what is meant by interference. How many types of interference? How to get the expression for the interference? It is a lengthy chapter out of 3 chapters. When definition, when 2 or more light waves traveling in a medium, light waves superimposes, combines, superimposes with each other, then amplitudes or modification of amplitude, energy and the intensity takes place due to superimposition of waves. This process or this phenomena is called interference. How to understand the interference concept? If you are perfect a little bit in wave chapter, if time permits, go through that chapter once again. Stationary waves, beats, Doppler effect, those are all interference in sound waves. This is interference in light waves. Stationary waves, interference. Beats formation, interference. Formation of nodes, antinodes in case of stationary waves. In case of beats, waxing and waning. Stationary waves, interference of sound waves with respect to distance. Beats concept, interference of sound waves with respect to time. Now the same thing we are studying in case of light. If you are perfect in that one, this concept becomes very easy. Choice is yours. When 2 or more light waves traveling in a medium superimposes with each other, then what happens? Modification takes place. Modification, changes will take place. The changes will take place in three quantities. What are those three quantities? Amplitude, change in amplitude, change in energy, change in intensity of light. This phenomena is called as interference phenomena. Interference phenomena. Let us consider a simple diagram to understand interference. This is one light wave. This is another light wave. This is another light wave. We can take any number, but for simplicity, we will take only 2 or 3. Only 2. Amplitude of the first light wave, A1, A2, A3. Intensity, I1, I2, I3. Energy, E1, E2, E3. This is first light wave. This is second light wave. This is the third light wave. 3 light waves are traveling in a medium. The first light wave, amplitude A1, intensity I1, energy E1. Second light wave, amplitude A2, intensity I2, energy E2. Third light wave, amplitude A3, energy E3, intensity I3. These 3 are traveling and they meet at a point. Superimposes at the point P. They will combine. We will get a resultant wave. We will get a resultant wave. Further resultant wave. We will get a resultant light wave. Further resultant wave. Amplitude is A. Energy E. Intensity I. Modification takes place. Either increases or decreases. We will see when it increases, when it decreases. This A different from the graph A1, A2, A3. This E different from the graph E1, E2, E3. This I different from the graph I1, I2, I3. Modification takes place in amplitude, intensity, and the energy of the resultant wave. This phenomena is called. This phenomena in which the intensity changes, amplitude changes, and energy changes. That phenomena is called as interference. We have to find out resultant amplitude, resultant intensity, resultant energy. Resultant energy. So this is about a small information about the interference. Tomorrow we will go in deep about the interference. Thank you.
Ma, next class is not there, ma. Vishwanath sir is not feeling well. So sorry for the inconvenience. So next class starts at 1 p.m.
You can take rest.
You can take rest. Have a nice day.